Hi everyone, my name is Phương. Our team SCMC15. We also have Minh, Khánh, and Hưng. In this video, we're gonna deliver to you guys the contents of spam and malware detections. Firstly, it's about our main homepage where we deliver to you guys, introduce the journey, some the thing that this website delivers. We have the dark and the light mode for users, for flexibilities. The about page for introduce ourselves, and going to the main page detection, we deliver the content of detected spam email or SMS. If the input will too long, then we will notifications about the lower accuracies. We can select on the model or we can select several of them for detections. Then the result will be delivered to users. We also have the URL and we may use some we may paste in some URL. The URL also have input validations like the text one here. And for the file, also like that, we can upload the file and text. The input content will be hashed into database for protect the user privacies. And in order, we provide a service of seeing the histories of detection. For that, we need to sign in. We can create an account or we can sign in. We already have an account. And I also allow user to log in as Gmail or GitHub account. Here, from that we can see the past. In the detection page, we can see the recent newest 5 detections, and we can go to the history page where with a pagination list out all of the detection in the past. For the admin, this account is an admin, so there will be a page for the admin to manage all the users, manage their emails, their roles, or create a new one. And for the account, there will be a reset password where we can type in the email and the OTP will be sent into our Gmail. Here. From that, after the code verify, we can enter the new one. One additional feature is about the user experience. It's a contact page. When user, there's a form, a frequent ask, or the form for user to fill in, and they may be testing some problems. The email will be sent directly. The message will directly send to my Gmail. Here. Moreover, about the data in this about the visualization, there are 2 types. The first one is the static data, which is the fixed data we show about the performance, the results of the models in the past in the visualization page. The second one is the static data, which is the real-time data, how this website is delivered to user. We put it in the homepage for user to view it. All the information is from the database and is updated by WebSocket with real-time syncs. And for the cybersecurity, we have the robotics to block any threat actors accessing the websites. About the responsive, we will also have the content for here. We have allow user on mobile to see our website also. And now our team will tell you how to do it briefly and how to deliver to the EC2 with load balancer, and you guys can also access by your device. One additional feature, really special one, is about the chatbot. The chatbot is the place where provide users with a system. This one we have already displayed in example 2, and we just deliver to example 3. This is not a call API. This one is the checkpoint from the LLM pre-trained with the APK instruction dataset about cybersecurity. Here we go. We have the answer from the chatbot, and even there are some citations.
I will talk about how what happens when a user creates a new request. So when the user fill out the information in this form, and it will create a post request to the front end, and then the front end will call the API endpoint, which will then go to the back end and will then go to the processing pipeline. And then once the result is returned, the backend will send a new record to the database. So now I will show you how this works. Talk about how the front end work with the backend. When a user clicks start detection on the detection page, it will call the use detection hook, which will select the correct API endpoint depending on the input type, and it will call the API using Axios, and it will call this API file here, and the API will select the correct route. So we could see we have many routes here, and once the scan is completed, then a new database record is created and sent to Superbase, and as well as the WebSocket will receive a broadcast for the real-time update as well.
So hello everyone, hello teachers. So we will talk about our deployment architectures. So we deploy the entire system on a single AWS EC2 instance with the 8 GB RAMs, which is we use the M7i's flex large instance type. And we use the elastic IP to ensure the stable access. And everything is containerized using the Docker Compose. And we separate into two Docker files, the Docker file for the backend and Docker file for the front ends. And we use Docker Compose to compose these two files. And also the Docker Compose and Docker is used to keep our development and production environment consist and avoid the common deployment issues. The Ningis is used as a revert proxy to route the traffic efficiently. The front end, let me move to this one. The front end request to the Next.js app, while the API call are handled by the fast API backends. And we also apply the several optimizations. The only challenge that I want to mention is the AI model consumes a heavy RAM. The risk of OM crash at 8 GB. So the solutions of our team is we create a auto monitoring script to restart the backend when the RAM exceeds to 7 GB back to zero manual interventions.
Hello, my name is Nguyễn Đông Khánh. One of our key design decisions was to structure the system around multiple model levels, ranging from basic machine learning models to more advanced approaches. This layered design allows users to compare performance across different levels rather than relying on a single prediction, which improves transparency and educational value. We also decided to separate model execution from result aggregation. Each API call processes only one model, while the front-end handles combining results from multiple models. This keeps the back-end modular and scalable while still supporting flexible multi-model evaluation. Another important decision was to support multiple input types like text, URL, and file within the same unified architecture. This aligns with real-world cybersecurity scenarios where threats can come from different sources but need to be analyzed consistently. In terms of challenges, one major issue was balancing model complexity with limited time and computational resources.